Let's take a look at solving polynomial inequalities. We're going to look at the process to solve them, and we're going to look at it graphically to try to tie these two together. So suppose we're given this polynomial inequality. So this is really asking where are the y values of the polynomial function x minus 1 times quantity x plus 2 squared. Where are the y values from that greater than or equal to 0? That's what this is really asking. So think back to our study of polynomial functions. We know they're predictable and continuous. We know that their end behavior is predictable. So what that means is if we're away from the area of the graph that the function is crossing the x-axis, the function's going to keep doing the same thing that it is doing. That's what end behavior is. So notice that this polynomial function is going down to negative infinity as x goes to negative infinity, and it's going to continue to do that. Unless it has a 0 somewhere over here to the left, it's never going to start turning around to go up to positive infinity. And likewise, this end over here. So the place where polynomial functions change and do weird things is around the x-axis, or wherever its zeros are. So that's why you always set a polynomial inequality relative to 0 and first solve the equation, because you're getting these zeros, these places where the polynomial might behave differently than the end behavior. So this guy's already factored, and I have two zeros, x equals 1 and x equals minus 2. Note that x equals minus 2 has a multiplicity of 2. So we've seen before that means that the graph touches and turns around. Another thing that means is that if the y values are negative to one side of minus 2, that means they're negative on the other side of minus 2. Or if they're positive on one side of minus 2, they're also positive on the other side of minus 2. So that's one thing to keep in mind. Here, with that multiplicity of 1, the y values are definitely going to change sign as the graph crosses when x is 1. So factoring this polynomial and getting the zeros is going to break up the x-axis into 3 intervals. We have 2 zeros, so that means we have 3 intervals to check, because we're going to check values to the left of minus 2, because we know that any value to the left of minus 2 is going to have the same sign, because the polynomial's end behavior is predictable. Any value to the right of 1 is going to have the same sign, because the end behavior of a polynomial is predictable. So the only place that the polynomials are going to be changing signs is around the zeros. So we want to check, first we'll check the first interval that's made up by looking at numbers to the left of minus 2. So that's this interval minus infinity to minus 2. So I can check any number in this interval, minus 3, minus 4, minus 117, because that end behavior is predictable. So I'll pick an easy number, x equals minus 3. I'm going to evaluate the polynomial there, and that gives me a negative value. It's less than 0. So remember our original inequality, we want x values that make it greater than or equal to 0, so this does not satisfy it. So we can disregard this interval of the x-axis in our solution. Now remember, x equals minus 2 had a multiplicity of 2. So that's telling me that since the y values were negative to the left of minus 2, they're going to be negative to the right of minus 2 as well. But we'll just check that interval between minus 2 and 1 for fun. So again, we can pick any number because polynomials are predictable and continuous. So I'm going to pick 0. That's in this interval from minus 2 to 1. Again, I get a negative value It does not satisfy inequality. And then that, like I said, that was expected because x equals minus 2 has a multiplicity of 2. So then finally, I'm going to check this third interval to the right of x equals 1. Again, I can pick any number from that interval. So I'll pick an easy number. This should say p of 2. Sorry. So I'm picking 2. And when I put 2 in here, it does satisfy the inequality. I'm going to change that. Forgive me for not remaking the video. So that does satisfy our inequality. So this interval to the right of 1 is part of the solution. Now notice that our inequality was greater than or equal to 0. So that means that I include the endpoints. Again, I messed this up, but I'm not going to redo the video because videos take quite a while to do. There. So our solution is 1 to infinity. That is where the inequality is satisfied. And we can verify that with the graph that those y values to the right of positive 1 are all greater than or equal to 0.